Today, Physical Sciences Inc. will present a novel technology for reducing the production cost of carbon fiber reinforced components. PSI's electromagnetic heating applicator can be installed in existing autoclaves or curing ovens to volumetrically heat carbon fiber components with precise electronic control. We've co-developed simulation tools for predicting the heating response of carbon fiber materials to electromagnetic radiation, which the Navy can use to design electromagnetic curing manufacturing processes. Physical Sciences is an employee-owned contract research and development small business with over 250 employees. In our 50 years, we have addressed numerous problems for the national defense, energy, and health markets. PSI's deployable technologies area develops high-power electromagnetic devices for both counter-electronic missions and manufacturing processes. PSI's technology responds to a Navy need for simulation tools and electromagnetic curing of carbon fiber composites. Electromagnetic curing of carbon fiber components provides an opportunity to significantly reduce the cure time and energy consumption of carbon fiber processing. In addition, there is some evidence that electromagnetic processing leads to elevated mechanical properties in the finished parts. The Navy needs a rapid simulation methodology for developing electromagnetic curing processes with laminates of varying thicknesses and fiber orientations. The Navy needs an electromagnetic applicator to apply heat uniformly to large area carbon fiber parts. Existing simulation tools for modeling electromagnetic heating of carbon fiber materials are too computationally complex for rapid process development and don't capture electromagnetic interaction with varying laminate weave patterns and toe sizes. Existing electromagnetic applicators used for metalworking are also not appropriate for applying even heating to large, contoured carbon fiber components without incurring hot spots, which locally degrade the material and induce thermal stresses. Navy program offices that require carbon fiber processing include several aircraft, helicopter, ship, and submarine platforms, including PMA 265, the F-18 program office. Commercial suppliers of carbon fiber components also have a need for electromagnetic curing to reduce production costs and lead time. On our Phase 2 STTR program, PSI developed an electromagnetic applicator for curing carbon fiber laminates with thicknesses of up to 10 millimeters. We co-developed a multi-physics simulation model which uses an effective medium theory calculation to greatly simplify the mesh of coupled electromagnetic and thermal FEA simulations. PSI's GUI allows Navy users to input the laminate stack sequence and output the effective permittivity of the laminate with less than 10% error when compared with experimental measurements. We showed our electromagnetic curing process achieves equivalent or superior flexural mechanical properties with ASTM-tested coupons, including a 6.2% increase in flexural modulus compared to oven-cured coupons. We also showed that electromagnetic applicators may achieve up to a 40% reduction in cure time and total energy usage. PSI's technology is currently TRL3, having demonstrated critical experimental function in the laboratory environment with an electromagnetic curing breadboard. By the end of the Phase 2 option, PSI will have a TRL5 electromagnetic applicator with a corresponding simulation methodology that captures the carbon fiber heating with accuracy. PSI's Phase 2 program will conclude with a production part curing demonstration, which will inform a cost-benefit analysis for marketing the technology. PSI's electromagnetic applicator will reduce the cure time and energy consumption of carbon fiber manufacturing processes by 40%. The associated simulation software will allow Navy users to rapidly adapt electromagnetic curing for a variety of carbon fiber laminates and components used in Navy platforms. The scheduling freedom and adaptive modeling approach will reduce both scheduling time and cost for the Navy. Improved mechanical properties will lead to structures with increased specific stiffness, reducing the weight of Navy platforms. PSI's transition goal during the Phase 2 SSTTR is to show electromagnetic curing of a DoD carbon fiber production component and compare the cure time and energy consumption directly to existing autoclave or oven curing processes. PSI will generate a cost-benefit analysis showing the utility of electromagnetic curing, which can be used to market the technology for further research. PSI will work with composite energy technologies to demonstrate curing a production part. PSI is actively engaging with DoD primes, including Northrop Grumman and Boeing, to determine how our technology may be integrated into their carbon fiber production processes. PSI will pursue transition with the Naval Air Warfare Center Aircraft Division, and specifically PMA 265, the F-18 Program Office. PSI will also engage with Navy Mantech and the Composite Manufacturing Technology Center to pursue further research programs. PSI is partnering with commercial firm Composite Energy Technologies to integrate our electromagnetic curing process into their carbon fiber component production. PSI's collaboration with CET will demonstrate our novel curing process, achieving equivalent or better mechanical properties with finished laminates compared to existing curing methods. We will work with CET to demonstrate significant reduction in production costs through a cost-benefit analysis centered around a production part manufacturing demonstration. PSI's business model is to license our multi-physics simulation software to commercial companies like CET so they can use the software to discover avenues for cost reduction and design electromagnetic curing processes. PSI will sell electromagnetic applicators that are specifically adapted to carbon fiber components to CET and other commercial suppliers of carbon fiber parts. PSI will incorporate a similar business approach with the DoD and DoD prime contractors. We will work with the Navy to apply our simulation software to various DoD-sourced components, including those used on the F-18 platform in PMC 265. We aim to sell our electromagnetic applicators to DoD primes for use in curing processes, as well as part warming, joining, and repair processes. PSI will use our cost-benefit analysis developed with CET to market this technology to prime contractors such as Northrop Grumman, Boeing, and Lockheed Martin. We thank you for your time and encourage you to reach out to learn more about our technology capabilities.